In this video, we will perform an eco audit of a bottle of water that is filled, transported 350 miles, refrigerated 2 days, and consumed. We will specifically look at a problem with 100 bottles of water, where the bottle is made out of PET, the caps are made out of polypropylene, and the water has a mass of 2 pounds. You can see I've also given you the other parameters of our eco audit, such as the amount of recycled content, the mass of each of the parts, how they're made, and what happens at the end of the life, whether they are recycled or go to the landfill. For transport, we see that it's transported on a 14-ton truck, and the use, we'll just leave the product life 1 year, but the use is that it's going to use electrical to thermal energy for the refrigerator. This takes 12 kilowatts. And it is done for 24 hours a day for 2 days before it's consumed. So these are the parameters that we'll be inserting into our eco audit. You can always go back to these if you need to refer to them, but those are the numbers I'm going to be using. To perform our eco audit, we go into CES Edupack, and first we need to select our database. To change this, I need to go to Change, and I see my databases, and I want to scroll down to level 3 with Eco Design. This is going to be required for the eco audit. Now that I'm on Eco Design, I go up and I select the Eco Audit button. This brings up the Eco Audit window. In here, we are going to need to define our product and insert all of the materials and the information of what it's made out of, how it's transported and used. So we're going to go through that with using the parameters that I gave you. The product name, that's going to be a bottle of water. Now we move on to the materials. So for each component, each part of the bottle will define a component. So the first part is we need 100 bottles. So our quantity is 100. The component name, we just call it bottles. And now this is the material. The material is PET. So we click on this symbol and we go to polymers. It's a polymer. It's a plastic. It's not a stretchy elastomer, so it's a plastic. And it's a thermoplastic. Here we scroll down. Remember, it's made out of PET. So we scroll down till we get to polyethylene terephthalate. Double click on it. And it's just native PET. There's no other materials filling it, so we want to choose unfilled. And it's going to be amorphous. So we've selected our material, which is amorphous PET. Next, we see the recycled content. So there's no recycled content in here, so we'll say 0. And we enter our mass. That was defined as 0.08 pounds. Our primary processing method we'll select, and that's going to be molding, specifically blow molding, but this is what we'll enter. There's no secondary processes. The percent removed, that's referring to secondary processes if you remove some from machining. And then at the end of life, this is going to be recycled. So we'll select recycle. And the percentage that's recovered, that is going to be 100. Next up, we'll add another material. So here we are going to add 100 bottles. Now we need 100 caps. Same thing, we'll go add our material. It's polypropylene. Unfilled, and this time it's been specified as a low flow homopolymer. The mass is 0.001 pounds, made via polymer molding. And this time, rather than going to landfill, or this one's going to go to the landfill. So we have one that's recycled and one that goes to the landfill. And now we also need to add in our water. So we click over here, add another material. Now I have 100 pounds of water. Well, not 100 pounds, 100 units of water. The material, we don't need to enter a material because we're not manufacturing it. We're ignoring that. But we just need to enter that there's 2 pounds of water. End of life, we don't specify end of life. We drink it. In this case, we're ignoring any joining and finishing. And so we just need to now, these are our materials. So now we need to know if we have these materials, we put them all together, how do we transport them? We said we need to move them 350 miles, so we need to enter that. So we'll click on transport. Name is just shipping. Again, these names just need to be descriptive. And our transport type, we specified that our transport type is a 14-ton truck. And the distance it travels is 350 miles. So I'm just filling this in with the information you've been provided. We scroll down. That's how we transport it. Now we need to use it. Again, we'll ultimately need to drink it, but before we drink it, it's going to be refrigerated for 2 days. So the product life is we'll just leave it at 1 year. The product uses the following energy. So it's going to convert electric energy to thermal energy, and the power rating is going to be, that's been specified as 0.12 kilowatts. So I'll just change this to kilowatts. Our usage is 2 days per year and 24 hours per day. In this case, we don't need to worry about a mobile mode. We already took care of that with our shipping. So now that we've entered all of our information, we can generate our report. To generate our report, we're going to click on the detailed report. So this gives us our Eco Audit report. You can see it gives us the energy as a function for each of these processes. So material, manufacture, transport, use, and disposal. And so we can see a lot of the energy goes into the materials as opposed to the manufacture or transport. We can also look at our CO2 footprint by scrolling down. We see that a big contributor to our CO2 footprint is the material over here. The last parameter that we need to define is this EOL potential that keeps showing up on our graphs. EOL potential stands for end of life potential. And so the way that Granta defines this is the end of life potential this represents the end of life savings or credits that can be realized in future life cycles by using the recovered materials or components. So this is saying when we have a negative EOL potential, this is telling us that the recycled PET, polyethylene terephthalate, remember we said that the bottles are recycled? So this is telling us that if we instead for the next time we make bottles rather than using new PET, if we use recycled PET, then our material CO2 footprint will go down as a result of this potential that we've saved. We have to actually use this for it to be useful. We have to reuse the material or the recycled material, but this is telling us the future savings from our material.